Case study: Enhancing Cybersecurity Through AI-Driven Threat Hunting, a case study of TechGuard's proactive defense strategy. Implementing AI-driven threat hunting is pivotal for advancing cybersecurity, underscoring the necessity to develop systems that preemptively identify and neutralize threats to digital infrastructure. Consider the scenario of TechGuard, a mid-sized technology firm specializing in software solutions for various industries. The company faced an increasing number of cyber threats due to its growing client base and the sensitive nature of the data it handled. To enhance its cybersecurity measures, TechGuard decided to implement an AI-driven threat hunting system. The team involved in this initiative comprised the Chief Information Security Officer, the cybersecurity team, data scientists, and software developers. The primary objective was to create a system that could proactively detect and mitigate potential threats using advanced AI methodologies. Central to their strategy was the use of machine learning algorithms. Training these algorithms required extensive datasets of historical cyber attack data. The team utilized supervised learning techniques, feeding the system labeled datasets of known threats to help it learn to identify similar patterns in new data. For instance, how can supervised learning be employed in cybersecurity to enhance threat detection? The supervised learning approach allowed the system to classify new data and flag potential threats based on the patterns it had learned. However, not all threats conformed to known patterns, which led the team to incorporate anomaly detection into their threat hunting framework. This involved identifying deviations from baseline activity. For example, the system noted an account exhibiting unusual login times and access patterns. How can anomaly detection improve the identification of previously unknown threats? By employing statistical methods and clustering algorithms, the system was able to detect outliers that traditional methods might miss. The integration of deep learning techniques, including convolutional neural networks and recurrent neural networks, enabled the system to analyze high-dimensional data sources in real time. For instance, RNNs were particularly effective in modeling sequences of login attempts and file accesses, which helped identify suspicious behavior indicative of a potential breach. What advantages do deep learning algorithms provide in processing large volumes of data for threat detection? These algorithms could pinpoint complex patterns overlooked by conventional models, significantly enhancing the system's threat detection capabilities. Natural language processing added another layer of sophistication to the threat hunting system. By analyzing emails, chat logs, and social media posts, the system could detect keywords and phrases that might indicate malicious intent. The team leveraged NLP to monitor communications for signs of phishing attacks and other social engineering tactics. How does NLP contribute to the proactive identification of threats based on communication patterns? This capability enabled TechGuard to stay ahead of attackers by identifying and responding to threats based on analyzed language. The vast amounts of data generated by the company's operations necessitated the use of big data analytics. The ability to process and analyze this data in real time was crucial for the efficacy of their threat hunting efforts. How does big data analytics enhance the detection of sophisticated threats within extensive datasets? Advanced data processing techniques allowed the system to uncover patterns and correlations hidden within large volumes of data, facilitating the identification of complex threats. A real-world example of the system's effectiveness occurred when the AI-driven threat hunting system detected a series of unusual transactions within TechGuard's financial records. These transactions were indicative of a coordinated cyber attack targeting the company's financial assets. The system flagged these transactions, prompting an immediate investigation. What steps should be taken following the identification of potential threats by an AI-driven system? The cybersecurity team was able to respond swiftly, mitigating the threat before it could cause significant damage. While the technical implementation of AI-driven threat hunting was a success, the team was mindful of the ethical considerations associated with AI in cybersecurity. Concerns about privacy, bias, and accountability were paramount. For example, the data used to train the machine learning models needed to be diverse and representative to avoid biased outcomes. How can organizations ensure that their AI-driven systems are ethically sound? By using fairness-aware algorithms and establishing clear governance structures, TechGuard aimed to mitigate these risks and ensure responsible AI deployment. In conclusion, the integration of machine learning, anomaly detection, deep learning, natural language processing, and big data analytics provided TechGuard with a robust AI-driven threat hunting system. This comprehensive approach enabled the company to proactively detect and respond to potential threats, significantly enhancing its cybersecurity posture. However, the implementation of such advanced systems must be balanced with ethical considerations to maintain trust and accountability in their use. By addressing these concerns, organizations can achieve a higher level of security and effectively safeguard their digital infrastructure.